global to national to military to human security threats we all are facing, and the role of technology in their security, then welcome to this channel, Threat, Security and Technology. In today's video, we will explore the dual nature of artificial intelligence or AI in enhancing security as well as creating new threats. We will also explore the role of AI in complete security ecosystem from geopolitics to global and national threats, military and homeland security, technologies and industry. We will find in many areas it is becoming AI versus AI. Hello, I am Rajesh Uppal, Director Founder of International Defense, Security and Technology Incorporated, a think tank in California, US for promoting awareness on international defense and security issues and technology solutions. I have also founded US-India Science and Technology for Security for facilitating US-India academia and industry collaboration on security technologies and systems. I was Director, System Analysis, Safety, Quality and Reliability in Indian Defense Research and Development Organization before I moved to US. Let us now discuss artificial intelligence technologies. The artificial intelligence technology aims to develop computers or robots that match or exceed the human intelligence in tasks such as learning and adaptation, reasoning and planning, decision making and autonomy, creativity, and extracting knowledge and making predictions from data. Within AI, there is a large subfield called machine learning or ML. Machine learning enables computers with the capability to learn from data so that a new program need not be written. Machine learning algorithm extract information from the training data to find patterns which are then used to make predictions on new data. Machine learning algorithms requires large training data sets containing hundreds to thousands of relevant features. Careful selection and extraction of these feature sets is required for learning. To solve this challenge, researchers turn to subfield within machine learning called brain-inspired computation, which mimics some form or functionality of the human brain. The average human brain contains approximately 86 billion neurons, which are its main computational elements. Each neuron contains multiple elements called dendrites through which input signal enter the neuron. The neuron then performs computation and sends the signal to its another element called axon. The axon then further branches out and then connected to multiple neurons through their dendrites. The connection between branch of an axon and a dendrite is called a synapse, and there are estimated 10 to the power 14 to 10 to the power 15 synapses in an average human brain. Neural networks, also known as artificial neural networks, is typically organized into layers. There is one input layer, one or more middle or hidden layers, and an output layer. Each layer contains multiple processing nodes or artificial neurons. Each node has associated weight and threshold. The data comes into the input layer and is subdivided into its nodes. The nodes manipulate the data and passes the result to the nodes of the next layer. The weighted sum of one or more middle layers is finally propagated to the output layer, which then presents the output of the network to the user. Deep neural networks or DNNs are neural networks with a large number of layers, typically from 5 to more than thousands. While machine learning could only learn classifications, DNNs are also able to learn relevant features. This capability allows DNN to be trained on raw video, audio and image data rather than feature-based training sets. DNNs are also able to learn high-level complex features compared to shallower neural networks. Deep learning, however, requires massive training sets, an order of magnitude larger than other machine learning methods. But if such data is available, they perform much better than other methods. Therefore, DNNs have become state-of-the-art machine learning algorithms that are employed for detecting cancer, to playing complex games, speech recognition, computer vision, natural language processing, to self-driving cars. The superior accuracy of DNNs, however, comes at the cost of high computational complexity. Both the training and execution of large-scale DNNs requires large computational resources, leading to high power requirements and fast communications. Researchers have been developing efficient hardware architectures for deep neural networks. Graphical processing units or GPUs are specialized microprocessors having parallel processing capability that are optimized for artificial intelligence and machine learning processes. Tensor processing units or TPUs are Google's customized application-specific integrated circuits or ASICs that are optimized for machine learning workloads. Few of the challenges are to create machines which have the energy efficiency matching that of a human brain, that is 20 watts of power on average, half that of a standard laptop. Then interpret and learn from data in real time. Then solve unfamiliar problems using what they have learned, and then adapt to new environments very quickly. The industry is now moving towards computing chips inspired by human brain, also known as neuromorphic chips. The neuromorphic computing mimics the behavior of neuron communication, which happens in the form of spike-like pulses, as well as neuron computation, which depends not only on the amplitude but also width as well as timing between the pulses. Neuromorphic chips achieves low power consumption by designing event-driven hardware for communication and computation. The neuromorphic chip also introduced efficient chip architecture by co-locating processing and memory on each individual neuron. This for each neuron can behave either the processing or memory element depending on the task at hand. DARPA defines different waves of AI. In first wave of AI, machine followed the rules defined by humans. The second ongoing AI wave includes all machine learning algorithms in which machine generate rules by clustering and classification and then use those models to predict and make decisions. The problem with deep learning is that it is a black box. We don't know the reasoning behind the decision it makes. That makes it harder for the people to trust them. Then also humans working closely with robot risky. The DARPA is now developing the third wave of AI theory and application in which machine will explain their decisions and adapt to changing situations. Intelligent machine, instead of learning from data, will perceive the world on its own, learn and understand it by reasoning. The intelligent machine then become the trustworthy and collaborate partners to shoulders in the battlefield. Let us now explore the dual nature of artificial intelligence and AI security ecosystem. AI is dual use technology, being employed by both civilian and military, both for beneficial and harmful ends. Artificial intelligence expands the availability and quality of data, leading to improved policy decision for benefit of society. Personalized medicine can extend life and also enhance the quality of life. Driverless cars can save thousands of lives every year worldwide and also enhance the mobility of the elderly and also with those with disabilities. Precise and customized education content can improve the learning and education. AI is expected to cause disruption by replacing certain kind of jobs, especially those that involve repetitive work from retail to market analysis to hospitality to warehouse labor. On the other hand, AI will drive innovation and improve human productivity by bringing new tools. AI is also affecting our privacy through mass data collection by companies and the use of facial recognition technology in offices, schools and other public places by some governments. Let us now consider AI geopolitics. AI can significantly enhance societal and economic benefits to the nations. The AI market is expected to reach 100 billion by 2025. Accenture, after analyzing 12 developed economies, found that AI has the potential to double their economic growth rate by 2025. Militaries are also racing to employ AI-enhanced communications, surveillance, data analytics, autonomous vehicles, and swarms to dominate the future battlefield. The economic and military advantages are driving intense AI competition between countries led by US, EU, China, and Russia to dominate in this strategic technology. Now let us consider dual nature of AI in national security. Terrorist groups have been using internet and social media to recruit, radicalize, and incite violence, then raise funds and buy weapons, distribute videos to their followers. In response, Twitter, Facebook, YouTube have removed millions of pieces of terrorist content using AI-based automated systems such as video and image matching, text-based machine learning. In future, the AI bots will detect hate speech, bullying, and other harmful behavior online and prevent them from being posted or remove them before significant harm has been done. Another security threat is deepfakes that uses AI ML to synthesize fake videos and audios. Criminals and nation states employ them to create celebrity pornographic videos, financial fraud, fake videos of politicians, and fake news to spread propaganda and influence elections, and also enhancing cyber attacks. Some of the deepfake detection technologies include multimedia forensics that examines each phase of image history to know when some data or information has been altered. Watermarking attaches watermarks to know when content has been manipulated. AI technologies like convolutional neural networks detects deepfakes through image feature analysis. After detection, the content can be deleted or marked as tempered. AI can also facilitate terrorists to carry out new type of attacks, such as packing explosives on drones and driverless cars. Intelligence agencies, in turn, are using machine learning and video analytics to analyze large amount of data and catch suspicious activities and criminals. Researchers are now employing AI for prevention of terrorist attacks. They are using AI algorithms for prediction and early warning of terrorist attacks based on global terrorism metadata, financial transactions, communication metadata, travel patterns, social media and internet browsing. Let's now consider the relationship between AI and cyber. Cyber attacks are continuously increasing in number as well as sophistication, causing immense financial and other damages. This new generation of malware and cyber attacks is also difficult to detect using conventional cybersecurity methods. Artificial intelligence and machine learning can be trained to find attacks which are similar to known attacks. The next generation adaptive machine learning algorithms will be able to collect intelligence about new threats, attacks, and breaches and learn from them. AI can also automate the complex processes of detecting and reacting to the breaches. In future, AI can fully automate cybersecurity. On the other hand, AI is enabling cybercrime as well as cyber warfare. According to Symantec, cybercriminals are developing AI-enabled cyber attacks that will cause explosion of network penetration, personal data theft, and epidemic level spread of intelligent viruses in the coming years. As nations are developing smart city infrastructure, they are also becoming vulnerable to cyber attacks. Advanced threat actors can use AI systems to carry massive distributed denial of service or DDoS attacks. These attacks will bypass traditional security tools and cause enormous damages to the operation of the infrastructure. Nation states and military are also developing AI-enabled extreme cyber weapons, including intelligent viruses to penetrate enemy networks. Again, we see dual nature of AI as well as AI versus AI as it is being used both to develop automated cyber defense as well as AI-enabled extreme cyber weapons. Let us now consider AI and military. Another threat is the dangerous arms race of AI-powered weaponry between countries led by US, China and Russia. AI is enabling many military capabilities and operations such as intelligence, surveillance, reconnaissance, identifying targets, speed up weapon development and optimization, logistics, command and control, and developing war games. Adversaries could use AI to carry out information and psychological warfare. AI systems can accurately analyze huge amount of data that is generating during peacetime and conflicts. It can quickly interpret information leading to better decision making. It can fuse data from different sensors to create a common operating picture of the battlefield. The AI systems can significantly react faster than those that depend on human systems. Therefore, AI is accelerating the complete kill chain from detection to destruction. This allows military to protect themselves more effectively against high-speed weapons, such as hypersonic weapons which travel at the speed of 5 to 10 times the sound. AI enhances the autonomy of unmanned air, ground, and underwater vehicles. It is also enabling concepts like vehicle swarms, in which multiple vehicles collaborate together to achieve a task. For example, drone swarms could overwhelm or saturate the enemy air defenses. Ultimately, AI is emerging as biggest multiplier of military and is being embedded in every platform, weapon, system, network, from soldier to entire military enterprise and making them smart and intelligent. For example, AI integrated with 5G and IoT are leading to smart military bases, soldier healthcare, and battle space awareness. Looking into the future, AI is enabling the next revolution of military, that is intelligentized warfare, in which there will be AI versus AI. We have to attack adversary AI systems as well as defend our own AIs. Let us now consider lethal autonomous weapon systems or laws. AI can also be divided into two categories: narrow AI and artificial general AI or AGI. Current systems are mostly narrow AI systems, which are purposely built to perform only a narrow task. In future, AGI systems would be able to learn, plan, reason, and communicate in the natural language and integrate all these skills and apply it to any task. One of the risks of general AI is that it would speed up development of lethal autonomous weapon systems. These systems can make life and death decisions without human intervention. Using sensor suits and artificial algorithms, they will autonomously classify a target as hostile, make an engagement decision, and then guide the weapon towards the target. Many organizations, including UN, have called for a global ban on lethal autonomous weapon systems. Moving beyond AGI is the concept of artificial superintelligent or ASI. ASI systems will become self-aware and self-vigilant and would be able to surpass human intelligence in every aspect, from creativity to problem solving. ASI systems could even present existential threat to humanity, according to some experts. According to Gary Marcus, professor of cognitive science at New York University, the smarter the machine becomes, the more their goals could shift. Once machines learn to reprogram themselves and improve them successively, leading to technology singularity or intelligent explosion. The risk of machines outwitting humans in battle of resources and self-preservation cannot be ruled out. We have come back now to a full circle again. We started with AI in global security, and now we find that AI is also a global threat. Let us see what solutions are being proposed. According to late physicist Stephen Hawking, the impact of AI would be cataclysmic unless it is strictly and ethically controlled. Unless we learn to prepare for and avoid the potential risk, AI could be the worst event in the history of human civilization. Ethics address the issue of what is right, what is wrong, and what is fair. According to one viewpoint, technology is merely a tool behind gadget or device Therefore, it does not have ethical or moral quality. Going by this viewpoint, it is only the tool developer or end user who decide and be responsible for the ethicality and morality of the device. Ethics of technology or technoethics is a subfield of ethics, coined by philosopher Mario Bunge to discover rationally grounded rules for the progress of science and technologies. Technoethics focuses on advancing the ethical rule of technology, protecting against misuse of technology, and discovering common principles to guide the advancement in technology and technological applications for benefit of. One of the technological solutions is the development of the fourth wave of AI systems. These AI systems will have common sense and understand ethics. They will make decisions based on rules, laws, and regulation to avoid their misuse. United Nations have launched an initiative, a Secretary General Roadmap on Digital Cooperation, which identifies 8 key areas for action. One of the key areas is global cooperation on artificial intelligence. Its aim is to build global capacity for the development and use of AI in a manner that is trustworthy, safe and sustainable, human rights based, and promotes peace. Thanks for listening. In future videos, we'll continue to explore various threat, security, and technologies. You are welcome to suggest topics of your interest in the comments below. I would be happy to address them first. If you want to participate in this fascinating journey of threat, security, and technology, please subscribe below.